All right, so this is a quick review of your Unit 4 Open Notes quiz. I'm just going to go over each problem one by one. You'll notice that in red, I wrote down the lesson number that these notes come from. So if you want to look back at those notes, if any of this is confusing or if I'm moving too fast for you, you can review those videos. So lesson 1 is L1, lesson 2 and 3 is L2 plus 3, and so on and so forth. So let's talk first about question number 1. What is the correct description of this reaction? So basically, you're taking this chemical equation and turning it into a sentence. Remember that S stands for solid, Zn stands for zinc. If you look it up on your periodic table, you can just look up Zn and the name will say zinc. So the only possible answer is whichever one starts with solid zinc reacts with hydrochloric acid in an aqueous solution or something like that, right? So if I look through this starts with hydrogen gas reacts with, that can't be true. B says solid zinc reacts with a solution of hydrochloric acid to produce a solution of zinc chloride and hydrogen gas. It pretty much describes this word for word, right? So solid zinc reacts with hydrochloric acid to produce, that's what my arrow means, a solution of zinc chloride and hydrogen gas. Right, so B has to be your answer. Moving on to number 2, what would you expect to see if you perform the chemical reaction below? The key word here is performed. So after this reaction happened, what should you see? Because I said after, that means you're looking specifically at your products. So I'm just going to look at my products and it says H2O liquid. So there's got to be some liquid, probably water, right? Because that's H2O, and some oxygen gas. All right, so if I have a liquid and a gas, I'm most likely going to see bubbles in a liquid, right? Because it's gas bubbles and so on and so forth. Right, so the correct answer is C for number 2. For number 3, which information can you determine about a chemical reaction from a complete chemical equation? 3 key words in this question: information, determined, chemical equation. Right, so looking at just a chemical equation, like the one highlighted here in yellow, what can you find out? So A says color of the products. This tells you nothing about any colors. All you know is whether it's aqueous, gas, liquid, or solid, denoted by these things in parentheses, or what type of compound it is, right? So you don't know the color of the product, so it can't be A. How fast the reaction occurs. It doesn't talk about that either, so can't be B. C says how much energy is released as heat. There's nothing about that in a chemical reaction, so it can't be C. D says formation of a solid precipitate. If you don't know what a precipitate is, it's basically a synonym for the word aqueous. Specifically and more accurately, it's a solid in a liquid. Right? So you can tell that there's something in the liquid if it's written as aqueous, so that would be formation of a solid precipitate. D is your only correct answer. For question number 4, where it says CO2S, which stands for solid, produces CO2G, which stands for gas, is an example of, you should have chosen a physical change, because here none of your atoms have rearranged, it's only changed its state or its form. So it started out as a solid CO2, now it's a CO2 gas. You can also think of it this way, where if I'm looking at the elements specifically, so here I have carbon that I highlighted in purple, and then oxygen that I'll highlight in green, O2 oxygen. In my products, I still have carbon next to oxygen. So nothing has changed. Purple is still with green, purple is still with green. You can like highlight elements by elements. It's kind of tedious, but it might help clarify a couple of things. So if you see no change in the colors, then it has to be a physical change. Or basically none of the elements are rearranging. All right, question number 5. Which chemical equation represents a physical change? Right, so remember a physical change is when none of your elements are changing. So if I said Na was yellow and Cl was orange, plus NaCl aqueous produces H2O and NaCl solid. So Na is with Cl in the products along with in the reactants as well. Right? The only difference is that you have an additional H2O, and this actually comes from the description here of aqueous, right? Because aqueous means in water. So in my reactants, this NaCl is mixed in with water. So I didn't write H2O, but in the products, I wrote H2O separately. In B, this would be an example of a chemical equation, because if I took the example of lithium plus H2O and color-coded them, I'll notice that in my product, all my colors are mixing, right? Or in other words, my elements are rearranging. Before, lithium was by itself. Now it's paired with O and H. Before, in my reactants, H2 was paired with oxygen. Now it's by itself. And in another scenario, it's paired with oxygen and lithium. Right. Number 4. Does the chemical equation below demonstrate the law of conservation of mass? Right? Your answer should have been yes, because there are the same number of atoms in each element in the reactants and products. A lot of you guys wrote A because there are the same number of molecules of reactants and products. Molecules change in a chemical reaction, right? CH4 and O2 no longer exist in the product. They are now become CO2 and H2O. So if I count out all of my reactants, I should find that I have 1 C, because there's no coefficient, no subscript, so that means 1. Hydrogen, I have 4 because my subscript is 4. For oxygen, my subscript is 2. If I erase that, you should see it better. So my subscript is 2. My coefficient is 2, so I'm going to take my coefficient, this number out front, multiply it by my subscript, which is also 2. 2 times 2 is 4. That gives me 4 oxygens. So 1 carbon, 4 hydrogen, 4 oxygen in my reactants. Whereas in my products, I have 1 carbon, my pen is not working. 1 carbon, there we go. 2 oxygens, and 2 times 2 is 4, so that's 4 hydrogens. And 2 times 1 oxygen is 2, so in total in my product I have 2 plus 2, which makes 4 oxygens. For 7, when you're balancing an equation, you should see just the coefficients, right? That's the only thing you can change, the number out front. Coefficients.